Today we're going to talk about the properties of logs. You've probably been asking yourself, what do we use these logs for? Well, we use a log to be able to solve an exponential function where the exponent is unknown. So when we did modeling in 7.1 and 7.2, so when we had exponential growth and decay models like compound interest, where it's compounded quarterly or continuously, or when we knew that a population was doubling or tripling, or we had half-life, and we didn't know the time that it took for something to happen, that's what we use log for. So we need to know the properties of logs so that we'll be able to eventually solve equations using logs. Our first property is the product property. So we're going to be using these properties both directions. So we're going to be looking at the left side, which is the condensed version of it, and then we'll be expanding it into the right side. Or we'll have the expanded version already on the right side, and we'll be condensing it into the left side. So if you see this product property, so log with some base of things being multiplied together. That's why x and y are next to each other. They're being multiplied. What we can do is we can expand it and we can separate it so that each one has their own log, and then we are adding them. So for the product property, if we have two things being multiplied together in a single log, we can expand it, and when we expand it, they get their own logs and we're adding them together. For the quotient property, notice this time we're dividing, right? That's why it was quotient. And when we go to separate the two logs this time, we don't separate it with addition, we separate it with subtraction this time. So the quotient property, if we're dividing two things, then when we separate it, it becomes minus. Or think of it this way, if whatever we have in the denominator gets a minus sign in front of it. All right, our last property we're going to talk about is the power property. So if you notice, we have x to the n power. So what happens is we take this n, that was this exponent, this power, and we put it in front of the log. So notice that's where the n ended up. It ended up in front. Okay, or if we go the other direction, if we have n in the front, then it becomes the exponent. Okay, remember, we're expanding or we'll be condensing, so both directions. And then lastly, I just added here, don't forget, when you have a square root or a cube root or fourth root or any root, that we can actually write it as an exponent instead, and that will be helpful when we use the power property. So if you see a radical, rewrite it as an exponent, and then you can use that property. All right, so let's try to expand a few. So I have log base 2 of AB. So that means A is being multiplied by B. So let's use our product property. So that means we're going to write each one with their own log. So log base 2 of A and log base 2 of B. And because they were being multiplied, we add them together. And we always ask, well, wait, why are we changing it from multiplication to addition? Well, it's actually because the log, when you evaluate it, and we talked about in the last video, was what was the exponent? Well, when you multiply bases, you add exponents. So that's why it changes to that. All right, so this is the final answer. Log base 2 of A plus log base 2 of B. Part B. All right, in part B, I see one log and I just see x to the fourth power. I don't see anything being multiplied or divided, just the exponent. So our power property says take this exponent and move it to the front. So our final answer for this one is going to be 4 log base 3 of x. Okay, and that's as expanded as it gets because there's nothing else happening. There's log of just x. All right, let's look at example C. So I have natural log of, I see x divided by y. Those are my only pieces. So they each get their own natural log, and because the y is at the bottom, it's being divided by y, it gets a subtraction. So natural log of x minus natural log of y, and that's what the quotient property said. All right, now in example D, I have a few more pieces. Okay, so I have log of, and this whole thing, I've got a 5, an x squared, a y, and I have a w at the bottom. So if I looked at 5x squared y and w, that's 4 different things. 1, 2, 3, 4. I've got 4 different pieces I'm going to have to separate. Please don't think that 5 and the x squared go together. Okay, they're actually separate pieces. They are also being multiplied like the first example of a and b. So all these are being multiplied and the w is being divided. All right, let's separate them all. All right, all the ones at top are being multiplied get addition signs. So log of 5 plus x squared gets its own log, log of x squared plus, because it's being multiplied, log of y. And then the w is at the bottom, so it gets subtraction, log of w. Now this would be our answer, except I still see an exponent. So this power, right, power property goes in front of its own log. It doesn't go all the way in the front, just of the one term that it was the exponent of. So our answer is log of 5 plus 2 log of x plus log of y minus log of w. And that is as expanded as possible. I don't have any variables next to each other, numbers or variables next to each other, and I don't have any more exponents. Okay, so let's go the opposite direction and let's condense. So we're going to take all these multiple logs, however many there are, and we're going to write it as a single log, as one log. All right, so in example A, I've got 2 logs there and they're being subtracted. So what happens is I write my single log, and inside of that log, for that subtraction, that becomes division. So I take 16 and divide it by the one that was being subtracted, which was 4. So that 4 goes at the bottom. That would be my answer, but sometimes you can simplify, so please do that. So my actual answer is log of 16 divided by 4 is 4. So that's my final answer for example A for condensing. All right, let's look at example B. So in example B, I see 2 logs and they're being added. So eventually I know I'm going to put those logs together and I'm going to multiply them, right? That's what the product property was. However, I can't do that until I get rid of any numbers in front. So this 4 that's in front of this log, remember the number in front? That's what the exponent used to be. So I have to fix that first. So I have log base 3 of 5 plus log base 3 of x to the 4th. And now I can put those logs together. So log base 3, so now it's a single log of, and what's inside of it? Well, because it was addition, I'm going to multiply 5 and x to the 4th, which can't be simplified. So that is my final answer. And I know I'm done. I've got a single log of something. And I can put it in parentheses or I don't have to. All right, let's try our final example, C. So I have quite a few terms here. So I've got log of x plus 1/2 log of 4. So I've got an addition sign. So that means when I put those together, I'm probably going to do some multiplying. But then I have minus log of 3, so minus means that's division, so that's going to be at the bottom, minus log of y. So there's another minus sign, so that's also going to be at the bottom. It's going to be divided. All right, so before I can actually put them together, I have to remember that if I have a number in front, I need to make that the exponent. So I now have, let's put them all together, log of, and I don't have a base number, so it's base 10, but I'll have to write it. Log of, and I'm going to put a parenthesis, and I remember I said some things are going to multiply and some things are going to be divided, so they're going to be at the bottom. So I've got a fraction. So the things at the top, things that are being multiplied are x, and now 4 to the 1/2 power. So I'm going to take 4 to the 1/2 power times x. Those are at the top. And then at the bottom, the things being subtracted go at the bottom, so the 3 and the y were being subtracted. Now that would be my answer, except this time this exponent is with a number, so I can actually figure out what 4 to the 1/2 is. And if I need to write it on the side, remember the 1/2 power means the square root of, so So this is the square root of 4, and we know the square root of 4 is 2. So sometimes you do have to simplify. So our final answer, log of 4 to the 1/2 was 2, and then x over 3y. I can't reduce 2 over 3, and I can't do anything with the x and the y. If they were both x's, we could maybe cancel them, but I can't. So that is my final condensed answer.